going back, I want to start by just talking in general terms, and then more specific terms, and then the rule. So I'm going to write underneath this. We're going to be looking at when things are perfect squares. So what we talked about last chapter, if I have a plus b squared, that's the same thing as a plus b times a plus b. Now, if you're having a hard time with all the pure variables, let's write right underneath that a real binomial that we can kind of compare it to as we work down the page. So 2x plus 3. So if that's 2x plus 3 squared, that's going to be the same thing as 2x plus 3 times 2x plus 3. That's what square means. Multiply it by itself. So again, going back to last chapter stuff, if I want to distribute that out, I'm going to multiply the firsts, the lead terms. So that's going to give me 4x squared. I'm going to multiply the next one. That's going to give me 6x. I'm going to do these guys, 6x. So they add up to 12x. And then I can do the lasts, 9. And that's what we did last chapter. Chapter 7 was about distributing out these binomials. In general terms, if they're just a's, it's going to look like this. A squared plus 2ab plus b squared. And when you track those back to each other, you can kind of see that I'm looking at the same thing here. A was 2x. So 2x squared is 4x squared. When I look at 9, that's 3 squared. And that middle piece, 12x, well, that's 2x times 3, which is 6x, times 2, 2ab. One of the things that you may have noticed as we've been practicing, so 2ab, that's the 12x, which is 2 times 2x times 3, is that quite often we keep coming across these perfect squares, where when we do the factoring, it works out to be x plus 1 times x plus 1, or x plus 5 times x plus 5. One of the things that makes this easier is if I can consistently recognize when I factor, which is working this backwards, I'm going to get that perfect square without going through all the tables and all the testing and all the guess and check. The key is to kind of learn how to recognize this special case of a perfect square. So let me show you what I'm talking about with that. Let's take this particular trinomial and say factor it. So factor, now I'll keep it simple. X squared plus, let's do 8x plus 16. Here's how you check to see if it is a perfect square without having to do all the tables and stuff. Question 1. So question 1. Is the first term a perfect square? So is x squared a perfect square? Yeah. Yeah. X squared is a perfect square. Question 2. Is the third term a perfect square? It's not? Are there two numbers I can multiply together to get 16? Yeah, what? 4 and 4. Third question. Is the middle term twice square root of the first, square root of the second. Now that seems kind of strange at first. It's like, oh, what do you mean square roots? Really what I'm asking is 8x twice x times 4. And those numbers come from right here. Here's my x. Here's my 4. Is that true? Yeah. So that means this does fit the model that we talked about back here. It fits this model of the first term is a perfect square, the last term is a perfect square, and the middle term works. It's a lot like doing the guess and check we've been doing, except that it's a slightly different format on it. Because when I do my normal guess and check methods, I look at the x squared. So this term here in this first lead term, well, that's x and x. My gut tells me 16 is probably 4 times 4, and then I can make my parentheses and guess and check. Yeah. If I can use this rule to shortcut it, I can say, hey, this is a perfect square. My factors are simply going to be x plus 4 squared. And then I can verify that by distributing it out to make sure it works. Or I could even say, let's guess and check the old-fashioned way. Oops. Here's where I want to be. X plus 4 times x plus 4. And see if that works or not. The nice thing about the perfect squares, is it's just a way to speed up the factoring for trinomials. I'll be honest, if you guys need to go through the longhand that we've been practicing because it's easier for you, that's fine. But if you can remember the rule, it will speed some of these problems up. Well, questions can I answer on that before I pause?